So if my lighting is bizarre, and I'll say this again during the show, it's because one of my lighting panels like suicided off of its stand right
Oh,
before
wow.
I contacted
Just went
Fraser.
for it.
Yeah, it totally went for it. Like it's somersaulted
Yeah.
because like I'm watching it go. I'm like, I can't catch that. Nothing I can
Yeah.
do. And then all the light goes out, and I'm like, oh no, it died. That's going to be so expensive. And it had literally somersaulted and landed light facing ground. And I picked it up, and oh, light. But it's now sitting on my desk, lighting me from this direction. And I have a light coming from that direction, which is leading to like what you see
Yeah.
on screen.
I, I I personally like a lower, like a dimmer lighting setup than a very bright one. So I think it's perfectly fine. I think it sets the mood. We're talking about space. You're
Yeah.
dark. You're you're just a glimmer of what's going on here, of Pamela.
I normally
Insights from the darkness.
yeah, I normally worry about the green screen. So, yeah.
Um, so to
Oh,
answer the
audio software.
question, um, to answer Alan's question, yes, we are planning a QA. I just posted the event, so it is now in the system.
Cool.
Uh, Alan Kitty says, Konnichiwa. Yeah, we're back from Japan.
How is your trip?
Oh, it was amazing. Yeah, yeah. What an amazing country.
So, I know you made no plans before you left, but what did you end
Yeah.
up seeing?
So we ended up. I'm gonna sneeze in a second here. Excuse me. So we flew into Tokyo and we spent about 8 days in Tokyo, and then we caught the bullet train to Kyoto and spent 3 days in Kyoto, and then we went down to Osaka and spent 3 days in Osaka, and then back to Tokyo for another day or two, and then we flew back home. And like I feel bad for the Japanese right now because their economy is has been stalled for 35 years.
Oh,
But what
God.
that means is that the prices are ludicrously cheap to go to Japan. Like
That's
you
not
like
normal.
guess how much it costs. Like these are small hotel rooms. Like no question, the hotel rooms are tiny.
Uh huh.
But guess how much a hotel room costs for like one person, like like a single bed hotel room in Tokyo?
I would expect no less than 150 a night.
$35. So it was so cheap that I just booked a
Like,
separate room for my son.
that's
Like I'm just like, you know what?
amazing.
We get our own rooms. So we just booked a room for me, room for him. Yeah, and then you could add the all you can eat breakfast buffet, which was like super high, like bougie
Yeah.
for $9. So it was so cheap. And I realized that it was just like there's no minimum, like as long as you're on Expedia and the average reviews are good, the hotel rooms are good. And so
Yeah.
even though you're only spending $35, $40, $50 for a hotel room US, the hotel rooms are fantastic. They're small, but they are fantastic. So and then the food is cheap too. So the best ramen you've ever had in your life for $5.
Yeah.
Right? Like it was bonkers. And then you feeling snacky, so you just go into the 7-Eleven, and 7-Eleven's there. Like the small convenience stores are like nothing we
Yeah.
have back home. They are filled with tons of variety. All the food is incredibly fresh, and so you can go get an onigiri, which is this little
I
rice
love
ball filled with,
those.
yeah, some kind of payload,
I can live on
salmon or,
those.
yeah, we did, and they are like $1, right? So you just like you go and you grab yourself a beverage and an onigiri or two, and you spent $3, and now you've got breakfast covered or lunch covered or whatever. And
It
so,
is
um,
absolutely
and
amazing.
then a lot of the things that we went into were reasonably priced. The transportation is amazing, just how logical it is. And it was weird because I was in going to Japan, I thought, okay, this is going to be a challenging place to travel.
No.
But it's the exact opposite. It was incredibly easy to travel there. That all of the all the signs are all in English. All of the devices that you interact with, they all have an option to
Yeah.
switch over to English, or Mandarin if you want. Everything, everything is said in English and Mandarin and Korean and Japanese, and so uh, it was effortless and a wonderful place.
So
So so clean, so efficient, so just the variety of 37 million human beings packed into this tiny area. There's a lot of fun things to do. So yeah, I highly recommend it. I'm gonna go back like soon.
so I
My other
was
kid wants to go to Italy. I'm gonna try to talk them out of it and take them back to Japan.
so Venice is pretty sweet, but so one of the things about Japan, and I was there in 2018, I think. One of the things that really confused me about Japan is it was a cash economy.
Yes, still is.
Yeah, that's so weird. I was
Yeah, I mean,
not ready for that.
you can definitely use your card now in like all of the stores, but for like accessing the rail system,
Yeah,
the vending machines, it's all still cash. And so
so
we're
weird.
constantly, I had a pocket in my backpack where it's just mountains of handfuls of change that you just dump into any machine that'll take it, and then
Right.
it sorts through and goes, here's what I need, here's what you've got, here's some change. You put it back into the bag. You just keep taking your bag o' coins and just dumping it into machines, and various good things come out of them. So, um, yeah, it's kind of amazing how much of a cash economy it still is.
That, yeah, was not prepared for
Yeah,
that.
but the tap works well now. A lot of places you give them your card, they put it into their machine. You don't even have to put in your PIN code in some cases, and it works. So
That's
so I think
amazing.
they're halfway there. I'm sure within a couple of years the whole place will be tap, and you won't have to think about it anymore. Yeah, yeah. So if you're on the fence and you're like, oh, I don't know, if you can get there, it is really affordable. And
That's
the place is
amazing.
just absolutely, and it is effortless to travel there, which was the biggest surprise to me because I was expecting for it to be, you know, a foreign language,
No.
totally different culture, everything's really complicated. Nope, piece of cake, easy as could be. And
The
especially with Google Maps, like navigating you onto the um like the Google Maps navigating you onto which train to take, which cars to sit in, which exit to look out for as you're leaving the station to get to your next train. It was all, yeah, yeah. The combo of Google Maps plus a really well organized transit system just made navigation effortless.
that is absolutely amazing. Um,
Yeah,
yeah, the only
yeah,
country I've really had issues in was Greece. Um,
yeah.
and I can handle the alphabet okay, but where I was getting disjointed was I was constantly going, okay, Google Maps is giving me in American character, Latin characters, and the Greek transit, everything is
Yeah.
in Greek characters. So I was constantly having to sound things out instead of pattern match. But
Right.
science prepares you for that.
Right. Yes. Yeah. You've learned a bunch of your Greek
Yeah,
characters.
yeah.
Yeah. All right. Let's do our jobs.
All right, I am pressing record. I have pressed record.
I am also pressing record and I've also pressed record. Astronomy Cast, episode 721, Rogue Planets. Welcome to Astronomy Cast, our weekly facts based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain. I'm the publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well, although one of my lights took a mighty leap right before we went live. So if you're watching this on YouTube, thank you for being here, and I apologize for my lighting. But you, how are you after your grand adventures?
Oh, it's great. We had an amazing time in Japan. It's surprisingly affordable. The travel was effortless. The level of English there is incredible. I can't think of anything that went wrong. I didn't
That's
buy my rail pass in advance. And so
amazing.
we had to pay cash for all of the rail that we did. We spent a lot of time in front of machines punching in destinations and putting in exact change to be able to go where we wanted to go. And it would have been a lot easier. But I think it was, we saved money, but it was a pain. But apart from that, the food was amazing. People were great. The accommodation was spotless. I can't recommend traveling and visiting Japan now more highly. So yeah, no, I can't wait to go back actually. I'm sort of like already think planning my next adventure back to Japan.
That All right, I need to go check airfares as soon as we're off this stream.
Okay. Most of the exoplanets that we found are around stars where they belong, but a few have been found free floating in interstellar space. The evidence is growing that there are a lot of them out there, maybe even more than planets with stars. How do they form, and how can we learn more about them? And we will talk about it in a second, but it's time for a break. And we're back. So, free floating planets, rogue planets, what are these things?
They are worlds that, by one manner or another, managed to not have a star. And what's cool is these isolated planetary mass objects may sometimes in just the right circumstances form completely on their own without a star, which starts to confuse what a brown dwarf is even more so. Um, or they get ejected from their solar system by one of several different
Right.
flinging, yeeting mechanisms.
Okay, well, before we get into how they exist, let's talk just about like how we found them. So, how did we first discover the presence of these free floating exoplanets?
It turns out that if you look closely, you can see them. Um, they were found originally in the Orion Planetary Nebula, all the way back, not planetary, the Orion star forming region. Sorry. They were originally found in the Orion star forming region back in 2000. If you look very closely, crawling across this rich star forming nebula, you will start to see proplyds of solar systems forming. You will see baby stars of every possible mass. And as you go, you will actually start to see some things of non-stellar mass. And this is how the very first ones were discovered, by two separate teams that published, not knowing anything about the other team, back in 2000.
And like 2000, so we
Yeah,
are
yeah,
24 years ago,
yeah.
and these are observations made with the Hubble Space Telescope.
And the thing is, that wasn't the only way that they were found. They were also found in the 20 teens. I don't know what we're calling 2011 at this
2010s,
point.
yeah,
2010s. I like 20 teens. It sounds good.
yeah.
There was also a group, a Japanese group from Osaka University, that was trying to understand uh, how much stuff is out there masquerading as dark matter. They were using microlensing to measure the presence of all of these otherwise non-luminous sources of mass. And while they were doing their survey, they came across objects, just a handful of them, that so briefly magnified the light of a star that the only way to explain the magnification was a planet massed object causing the microlensing event to take place.
And this is similar to this process of gravitational microlensing where they're finding exoplanets around a star. You get one star passing in front of another star, you get this distortion of the light, and then further distortions due to the exoplanets that are following the star as they're passing through, and you can actually measure the size and the mass of these exoplanets. But in the case of the rogue planets, the free floating planets,
No
you're
star.
just you're watching a star, no star, and then suddenly it gets a
Mhm.
distortion, and then the distortion goes away.
Very briefly.
And and yet all the information that you need is in that distortion, telling you the mass of the planet as it's passing in front.
And so this started with the Osaka University team led by Takashiro Sumi. A Polish team picked it up as well. And And since then, we've just seen team after team. We've seen things coming out of Ogle have gone looking. But with microlensing, the problem is you see the planet once and that's it. That's the only chance you've
Yes,
got. There's no
right. There's no
confirmation
follow-on
taking
observations.
place.
Yeah, yeah, it's over. Yeah, it's come, it's gone. But sort of back to that original Hubble discovery,
Mm-hmm.
Webb turned its eye on the same regions in the Orion Nebula. And what did it find?
It found over 500 free floating worlds, of which roughly 9% are binary free floating worlds, which
Okay,
is not something anybody predicted, not something anyone expected. And a recent publication may help us understand how the heck we get there. And I have to give a shout out to, and I apologize if I mispronounced your names, to McCullen and Pearson for their pair of papers that are working very, 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 very slowly through peer review. The discoverers of these binary objects put out a pair of papers on Archive. They're working their way through the peer review system. They are not peer reviewed yet, but the paper explaining how the non-peer reviewed results came to be is through peer review. So we have a bit of a
right.
point of confusion
Yeah.
here.
Okay. You know what? I want to leave the listeners on edge to find out how we could have such a thing, but it's time for another break. And we're back. All right. So free floating binary exoplanets. How?
So the thought is we have to take a step back first and look at one of the mechanisms that
Right,
allows
right.
these free floating planets to exist in the first place. So if you have a tiny solar system or a big solar system, it really doesn't matter, and it's happily has planets going round and round its star, um, and another star comes sweeping past, that star that goes sweeping past can gravitationally disrupt your happy little solar system and cause planets to fly away.
Right.
Now, the catch is if you have star with two planets that are on the same side of the star, and if when they're on the same side of the star, so they're gravitationally seeing each other, another star comes through, it's possible that those two planets that are presumably going in the same direction and that passing star's gravity can cause those two planets to hold on to each other
Right.
and lose hold of both stars. So it's a side swipe that
Right.
gravitationally disrupts the system and sends those two planets flying.
But right, and that's trying to explain. I mean, like if
Yeah.
all we saw in the Orion Nebula were these single planets, then these side swipes would make a lot of sense. And not just like a side swipe, but
Mm-hmm.
also planet, there's a lot of mayhem that goes on
Right.
inside in a planetary system.
So,
We know that we had this migration process, and so who knows how many planets were kicked out of the solar system early on. Okay, fine, but to see 9% of your exoplanets in binary
yeah.
pairs means that something happened to them together.
Yeah.
That side swipe seems like a bit of a long shot that you're going to get 9% of the time two planets are gently plucked away from their star and sent hurtling off into interstellar space. That's pretty out there.
It's the only published explanation we have
Right.
so far.
But what's the other mechanism, right? The other idea is that they just formed in place, that no star was ever
Right.
involved.
Right, exactly. So yes. And this gets back to what is the core set of ways that you can get these things. So rogue planets in general are thought to have either formed that way, to have been in a solar system and been yeeted out through three-body interactions within the solar system. So this is where interacting with some other world plus the star caused them to get ousted. Or um, side swipes occur. So
Mm.
either external force, internal multi-object dynamics causing yeeting, or they form externally. So it's also possible that you have these things forming independently in binary systems. And what gets me is we only see big things right now. We only have the capacity to be seeing these gas giant sized objects. We're not yet seeing free floating rocky objects.
Right.
And so we don't fully understand what is the frequency that these things occur to different size objects, what is the frequency at which different size objects can be free floating. There's so many things that we don't know. What we do know is there's this cool paper that just came out that is saying that you can, according to the numerical models, get two things gently removed if the side swipe is just right.
Right. But also there have been papers saying you can get a world, that you can get
Mm-hmm.
if you have less gas. I mean, think about like a dwarf, like a brown dwarf, right? You have a brown
Yes.
dwarf, you
Yes.
have less material. It is able to it doesn't have enough material to form a star, but there is enough that comes together that you get
Yes.
this failed star. And it might very well be that if you just have a smaller amount of material, you get maybe a Jupiter, and even less material, maybe you get a Saturn. But you're not going to get the same mixture of heavier elements that you might get in a more traditional star system, where you've got this larger gravity well, this
Right.
accretionist is pulling material in. You have these rocky areas that are forming certain kinds of
Or
planets.
I think another way to look at it is in a solar system like ours, you have massive quantity of mass that has sufficient amounts of the stuff and things that become rocky worlds that you can have rocky worlds.
Yeah,
But a single isolated cloud, even if it has the same ratio of materials, because the majority of the material is hydrogen and helium, you aren't going to get a rock out of a tiny cloud that is majority hydrogen and helium. You're going to get a gas giant that has heavier elements in the same frequency that they occur in our solar system, just mixed around differently.
yeah. All right, we're going to take another break, and we're back. So now we know these things exist. Do we have a sense of how many there are out there?
I love the dispersion in the papers I found so far. General suggestion is there's probably at least two per star,
Mm-hmm.
but there could be tens of thousands.
Yes. So
It's just
I
sort
know
of
exactly what you're talking about. Yeah.
how do you
What?
get from
Right. So, so let's imagine, right? There's say there's 100 billion stars in the
yeah,
Milky Way. So
yeah,
there could be 200 billion rogue planets, or maybe 10 trillion rogue planets
right,
moving around inside the solar system. And I've got to just stop right now. And people are going to go, wait a minute, could that explain dark matter? And the answer is no.
no,
Moving on. Yeah, it's not enough. Their planets are in the solar system. Rogue planets are 1% of the mass of the
yeah,
solar system. It is the sun that is the vast majority of the mass in the solar system. So no,
yeah,
rogue planets. If they were dark matter, then they would be shining, and we would see them and we would detect it. And they are not 10 times the matter. So sorry. But okay. So let's say that there is like even double is exciting.
right.
10, a
I'm gonna
thousand times more is incredibly exciting. But what does that mean then for how how far away these things are in the Milky Way?
so I think this means that we need to start looking more and more for newly discovered comets and asteroids that are on highly elliptical orbits. Are they alien in nature? And I don't mean
Mm,
little green men. I mean, did they come from other stars?
yeah.
I think if these things do exist in those tens of thousands kinds of numbers, we should be seeing a lot more interloping rocks coming at us from the great beyond. And that's cool. That's a way to get rocky samples from a solar nebula that wasn't our solar nebula. And I like that idea.
Hmm.
It also raises the probability of an interloping planet coming flying through our solar system. I want to see that story very much, please and thank you.
Yeah.
It it
But stay
also
far away. Like, don't get too close.
yes, yes. It also means that when we see these weird stars suddenly dims by X amount, um, we have new things to potentially blame. It means that there's a whole lot of junk out there that we need to figure out how to incorporate into our models. And that's
Yeah.
cool too. It's mostly
So
just a whole lot of this is interesting data. If it's only two per star, our models are fine. If it's 10,000 by star, why haven't they started interloping more and did we just not
hmm.
notice?
So let's talk about the potential for habitability.
Yeah.
Um, could there be life on these planets?
It depends on how old they are. So when they first form, they're going to be super hot. Just everything's super hot when it first forms. But over time, that internal heat is going to get radiated away. Over time, any radioactive materials in the mix are going to do their radioactive half life thing and stop being radioactive and start being completely different child particles. Over time, all of these things are going to just cool off to little frozen nuggets floating through the galaxy and beyond. It's hard to have life without energy.
hmm hmm But
But
we think about places like Jupiter with its icy moons and the heat for Io. Like Io is the most molten place in the solar system and
yeah,
it is not
that's
coming from the
tidally
sun.
heated.
Right. And so could you get this situation where you've got a giant exoplanet and moons that are tidally interacting and are being kept warm in the same way that Europa,
Yes.
Enceladus, and so on? Yeah.
Yes. So then it starts to be now we're looking at the case of life with no light, and there's no reason to think that can't happen because we have it
Mm.
at deep sea hydrothermal vents here on the planet Earth. Yes, if we manage to form rogue planets that take their moons with them or form with moons, and those moons have the needed constituent materials. So here we're looking at these minuscule clouds somehow having enough rock and water to form icy moons or to have stolen them when they got yeeted from
Right.
where they came. Um, yes, there is the potential. Now comes the question of is this the kind of environment, and we don't know yet,
Yeah.
capable of sustaining life?
And
And
you've also
it's
got the
possible.
the decay of radioactive
Mm-hmm.
elements, which are a big part of the Earth's internal
Yeah.
heat. And so you kind of add those together, and there's a chance.
Yeah.
But good luck learning anything
Right.
about them because
Yeah.
they're far and there's no star to illuminate them. So really, this is my next question: is how can we learn more? What can we do to find these things with more precision and learn more about them?
The frustration is like we know that the area of the Orion and the trapezium star forming regions clusters are super dense, and in that super dense environment we're going to find the rare objects. But once they leave, we're now looking for cooling objects, and JWST is going to be part of our ability to do that. But we're just going to have to hope that some of these objects are interloping in the fields we're already looking at.
Right.
Directed searches for them, JWST isn't a survey scope. I think our best hope is maybe we're looking at other background objects within the plane of the Milky Way for some reason, and there happens to be one in field. And that's what we're
Yeah.
going to be looking for is looking at other objects within the Milky Way. What's going on?
And there is a telescope that's coming that's going to be doing
Yes.
exactly this. This is the Roman Space Telescope, Nancy Grace Roman, and its larger goal is to be do this gigantic survey of the universe to try and map out the concentrations of dark matter, dark energy, and understand the expansion rate of the universe. But it has this incredibly wide field of view. It's looking for objects that change in brightness across this field of view. And it's theorized that it will find thousands, maybe tens of thousands of rogue planets through those microlensing events that you mentioned earlier on. So we are going to have a telescope that is going to find a lot of them, but and give you these overall, give us a number of how
Yeah.
many there are out there, give us a sense of their mass,
And
how massive are they, but it's still one and done. They pass through in front of the star and then they're gone and there are
yeah.
no more observation allowed.
But Roman is working in the infrared, so it also has the potential to do direct imaging of young ones. And we're going to have Roman at the same time that we have Vera Rubin. And with the LSST doing its survey thing across the sky, in the best of all possible worlds, we happen to catch some of these microlensing events with both scopes at the same time and get that confirmation.
Yeah.
More, I think Roman, I'm really hoping Roman does some direct imaging. And then Ruben is going to be catching everything. It's just that simple. Ruben is going to be catching everything.
Yeah. And there was a mission out a few years ago called WISE, and
Mm-hmm.
it was doing a infrared survey of the area around the solar system.
Mm-hmm.
In fact, we know that there are no large planets in the outer solar system, like no Jupiter-sized
Yeah.
world out to about 10,000 astronomical units, because of the the survey that was done by the WISE
Yeah.
telescope. But it also found brown dwarfs, things like that. So we know that if Planet 9 exists out there, it has to be roughly like between Earth and say Neptune size. Like
Yeah.
it can't be bigger because that's been ruled out. But there could very well be one of these rogue worlds. If they really are that dense as we're saying, then they're going to be within tens of thousands of AUs of the sun. Like they're out there around
Mm-hmm.
us, all around us.
Mm-hmm.
How does this sort of change your thoughts about exploring the Milky Way? Say we get to some far future where we're able to fly to another star system. Are these the destinations, not the stars?
So, I mean, it depends on what you're going for at the end of the day. There is the possibility that you get on one of these that has a particularly high velocity so that you can cover a larger swath of the galaxy in a given number of generations. But if you're looking at a world that is either just a frozen gas giant or a frozen gas giant with perhaps some warmed up moons around it, that require massive amounts of drilling equipment to get down to any liquid water, that's not the most energy efficient destination you could go towards.
Mm,
Um, I think that the idea of flying out to your Proxima Centauris as starting points is going to, for the time being, remain our ultimate short-term destination. I do, however, really like the idea of taking the idea of Jules Verne's off on a comet and turning it into off on a planet and setting up a future where this is how we explore the galaxy.
yeah, yeah. I love this idea that these rogue planets are all around us. They're passing relatively close to the solar system. What would have been a 1,000-year journey suddenly becomes a 100-year journey.
Yeah.
That these could potentially be refueling stops, or even if we map them out well enough, that they are gravitational slingshot points
Yeah.
that you can use to accelerate your spacecraft to its final destination. But it changes. I don't know. When I started to learn more about these rogue planets, it started to feel like that revelation that you realize that you're more bacteria than you are person. You know, that that the galaxy is more rogue planets than regular planets. We just don't see them because we only can see what's in around the stars.
Again,
And
maybe. It might be
maybe,
two per
maybe,
star.
sure. Yeah, merely two per star, or it might be more. It might be less. Who knows? Like we've got to wait for Roman to do its survey to
Yeah.
really tell us the answer. But it still sets my imagination on fire. I just think it's such a great idea, and I would love to know more. And hopefully, future missions, telescopes will know more,
I
and
want
we'll
an
eventually get to the point where
interloper.
we're
I want
yeah,
an
we're
interloper.
analyzing the
Imagine if a
atmosphere, the
Mercury just
weather.
suddenly flew through, like rogue Mercury coming for a
Yeah.
visit from another star. I'd
Yes.
be down for that.
Yeah, that would be amazing. Awesome. All right. Thanks, Pamela.
Thank you, Fraser. And thank you. I have so many names to get through this week. I'm not quite sure how we landed here, but I'm very grateful. I'm going to read out the names of a whole bunch of $10 and up patrons. Thank you so much for being part of our community. You allow us to have our staff take care of us as well as they do. This week, I'd like to thank Sergio Sansevrio, Brett Morman, Conrad Haling, Thomas Gazetta, Jarvis Earl, Tushar Nakini, Slug, Bebop Apocalypse, Bruno Lutz, Greg Davis, Bob Crail, Will Hamilton, Sterling Gray, Adam W., Semyon Torfison, Bert Weist, Gear Daly, Jeff Lichtman, Rick Norvald, Amber J., Morgan B., Sven Barter, Douglas, Bill Hedge, Douglas McLaughlin, Amy, Neil Beaton, David Killia, Max Haberman, Paul Lavelle, Vivian Rosez, Eric Gothier, Effman, Susan Busini, Tom Rosland, Richard Bloom, Meh McMurdo, Michael Friedman, Sandy Jester, Chris Affleck, Dania Daskasel, Seth Ambrose, Simon Bennett, Jorg Taparev, Royce, KJO, Craig Fisher, Kevin Miltello, David Johnston, and Brian Hager. Thank you all so very much.
Thanks, everyone, and we'll see you next week.
Bye bye. And then they saved. I lost the window. There's the window. I buried the window. And this time I'm going to remember to put it in the correct directory so that I don't force Rich to go spelunking
Yeah.
for it.
Yeah, you get the email from Rich.
Yeah.
Where's your audio?
Don't know.
Okay. I'm
All
uploading.
right. Everything is saved.
We are safe. All right. Hal McKinney asks, could a rogue planet have enough internal temperature to support life without a sun? I feel like we covered that.
Yeah.
There was one thing that I think you're not aware of, and so I didn't want to sort of put you into unfamiliar territory.
Thank you.
So I interviewed Ravi Koppelman, the guy who's behind the Haitian Worlds.
Uh-huh.
And one of the things that he said was the Haitian Worlds, because you've got these exoplanets with a thick layer of liquid water and a thick hydrogen atmosphere, you get dramatically different requirements for where the habitable zone occurs.
Mm-hmm.
And he feels that with enough radioactive elements inside the planet, that it could remain liquid water on the surface for billions of years. And so not if you've got the Haitian worlds that are in orbit around stars, but some of them could be free floating Haitian worlds, and they could actually have liquid water on their surface under a thick atmosphere of hydrogen.
That is
So,
cool. And you're
isn't
always
that cool?
welcome to bring up, I interviewed this guy.
I interviewed the guy behind the Haitian world, and I asked him this exact question. So, yeah, I thought that was cool.
Very cool.
And then Hal McKinney also asked, how fast do interstellar traveling objects like rogue planets travel compared to our fastest spacecraft? Should we have probes on standby to piggyback on such objects?
We can't catch up.
I disagree.
If they
There's
come
two
through
parts.
our solar system, we can catch up.
Yeah. So the one thing is to intercept them and do a flyby, and actually the European Space Agency is planning a mission called the Interstellar Interceptor.
Yeah.
And this is a tiny probe that's going to fly with the Ariel spacecraft in 2028, so just in 4 years. And it will hover at the L2 Lagrange point and wait for a target. And the potential targets are an interstellar object like Oumuamua or Borisov, or a long period comet that's going to fall into the inner solar system, and then fire its thrusters and go for it and try to do a flyby and take some pictures of the first object ever seen that came from outside the solar system. The other thing is there's a group called Project Lyra.
I
I
don't
don't know
know
if
that
you've seen
one.
their.
No.
So they are every year updating their here's how we could catch Oumuamua if we really wanted to, and then they describe the rocket that's neat. It's a Falcon Heavy could do it with a very tiny spacecraft. Now Oumuamua has gotten far enough away that you need to do an Oberth maneuver. You have to fly really close to the sun and pick up some velocity to be able to meet. But still, we could build a probe today and launch it and catch Oumuamua in about 30 years if we wanted to. But
It's
nobody
a
wants to.
bit controversial. There are other folks that are like, no, that's actually not feasible given the time it takes to build something. So the catch is, how long does it take something to be built? How long does it take to catch up? If you combine both those numbers, do you get there in the amount of time you have after it's been discovered?
Yeah, so they say yes, and they keep sort of updating their,
Yeah.
every couple 6 months or so we get a new Project Lyra update where they give the newest flavor of their proposal. But nobody really is willing to drop everything, build a probe, put it on a spacecraft and send it. So
Yeah.
so I think their work is becoming more and more useful for considering what it'll take to go to the next interstellar object.
Right. Right.
And then Hal McKinney also asks, would a rogue planet more typically be traveling away from the Milky Way's galactic core?
Say that
Do you have an
again?
opinion on that? Would a rogue planet be traveling away from the core of the galaxy?
I mean, on average, things are moving round and round, not on highly elliptical orbits. So, on average, they're going to be coming at us, or we're going to be catching up to them in the direction of motion around the Milky Way.
Yeah. Yeah. So they're just going to do star things.
Yeah.
SO says, my TV doesn't get the change channel signal if the armchair is in the way. How am I supposed to believe that we're still talking to the Voyager way the heck out there? Does your remote control have a 70-meter radio dish attached to
Right.
it?
That's the key.
Yeah. Does it? If it does,
And
then there's a problem.
most remotes are using infrared as well, and your armchair can block the infrared. Your significant other, including your pets,
Yeah.
can block the infrared, but the radio signals can pass through stuff.
Yeah. Through the atmosphere.
Yeah.
And so the Voyager's dish, I forget the exact size of the dish, but it's several meters across. And then it's transmitting, and
Yeah.
then the dish that's retrieving it is 70 meters across.
Yeah.
And they're only picking up a few bits per second. It is not a lot of bandwidth
Yeah.
that they're getting because it's so far away.
Have you had a chance to check on the status of Beppo Colombo today?
Not today.
It was
It's
sad
what's
last I looked.
yeah, it's the last I saw that it was sad. They've restored 90% of the thrust, and they're gonna make their next flyby,
Okay, so
is what I
they
know right
should
now.
make it to Mercury.
They've got 3 flybys to do, so
Yeah.
they're gonna perform their next one, no problem. I don't know the status of the 2 after that.
Okay.
And then it's temporary. This is the transfer module, and it's gonna get ditched when they get
Okay.
to um, when they get to Mercury, and then the 2 spacecraft will be on their own. So, yeah, they're gonna have to try and get through that. SOL asks, how is Voyager still powered? My batteries don't last that long. Again, does your
Ready.
remote control have a decaying piece pellet of plutonium 238 that is that has a half-life of 50 years in your remote control? Because if it does, then your battery should still work. But if it doesn't, it might be that your batteries are powered differently than the Voyager spacecraft.
And to the people commenting on my necklace, it's actually one that I made. And there's stuff similar to it. I don't think there's anything this big currently for sale, but there's stuff similar to it for sale on my Etsy store. So, Star Strider Studios on Etsy.
And then Hal McKinney asks if I did any sciencey things in Japan. Not really. This was a vacation and a chance to hang out in Japan with my son, and so I purposefully tried not to do any work while I was there. Um, we went to a science museum, which was kind of mediocre. I wish I hadn't gone
Oh,
there. Yeah, yeah, it was too bad. It was very, yeah, it wasn't great. Big, beautiful, amazing space. There was a really cool uh, Earth, which had all of the weather on Earth projected onto it, and it was
science on the
really neat.
sphere.
Yeah, yeah, on the sphere, and it was huge. It was like,
Hmm.
I don't know, like the size of my room, and so it was this giant sphere, and you could walk around it, this cool sort of walkway that went all the way around, circular. But the actual exhibits inside the museum they were not great. We weren't really impressed. Um, and there was another science museum that we tried to go into, but we arrived too early and they weren't open, and we weren't patient, so we just kept moving. Um, so that's it, really. I didn't do. I mean, I would have loved to have gone out to the actual science center, sorry, to the space center, and if it was just me, I would have been setting up interviews and you know touring facilities and meeting scientists and so on. But there's only
Kiddo.
so much yeah, yeah. My son wanted to see anime stuff, giant fighting robots, sushi, and so on. So, yeah. Um, SO asks, what is the space question that you wish someone would ask you, Pamela? I have the same answer.
What book would you like to see from the most recent science? And I will write it, is what I want them to say after I answer the question. I've decided I need to start a running list on my blog of please somebody write these science topics into a novel because I want to see them used.
Mm, like a science fiction book that incorporates. Give me some examples. What are some cool ideas that you would love
This
to see
rogue planet
incorporated?
idea. I mean, imagine
Yeah.
our solar system flying happily through the universe, and then it is spotted that there is a runaway star that's going to make a close encounter with our solar system at such an angle that it strips off like us and Mars or something.
Yeah.
Um, I would love to see the multi-generational space opera that comes of that.
Yeah. I I mean, there have definitely been some books that have been done about generation ships, and my perspective on a generation ship. I mean, Fallout kind of covers it.
Yeah, yeah.
Like when you think about the Fallout universe and the
The
various kinds of experiments that happen in the different Fallout shelters,
mhm.
that's essentially a generation ship, or the silo,
Yeah.
right? It's the same thing. And so trapping human beings, in that case, it's for survival. And so I think there's an expectation like, be glad you're alive. But once you are having people go to another star system, that this is a thing that your parents volunteered for. This human rights this ongoing human rights violation that you are trapped inside was chosen by your parents, um and I find that really fascinating, horrifying.
I
So
apologize for
I
the jingle bells in the background. I have Murder Dog just walked into the room.
right, I think of a generation ship as a human rights violation, and not as an inspiring story about people going to, another star system. No, you were born. What is my purpose? Your purpose is to be born to struggle for survival in a creaking starship that is losing functionality, to maintain it long enough to have children so that they can carry over for you, and then your job is to die. Welcome to the universe.
There's an interesting take on that in some of the Alistair Reynolds books, where there is a small cadre of humans that are kept awake while the majority of the humans on board the spacecraft are kept with their permission in cryogenesis.
Yeah.
And in those cases, it's like you are born into a cult, as Zap Van Satvan puts it.
Yeah.
but it is the cult of the keeping everyone else alive. And it's just sort of like that sideways of slavery, but still
Yeah.
slavery. I don't know what to
Right.
think
Yeah.
there.
I'm reading House of the Sun right now by Alistair Reynolds, so I'm not sure
Okay,
which one you're talking about, but don't spoil.
I won't.
Yeah. Um Bob LeBlanc says, "Go four legs, Starship Earth." Yep. Here we go. Um so anything other we're not streaming on Twitch, right?
No, no, I
Okay.
don't know why, but no, we're not.
Yeah. So Bob LeBlanc asks, um, any Arecibo-sized telescope observatory to be built anytime soon? Plans, 300-meter dish,
No,
uh,
fast over in China is all we've got for a while.
which is a 500-meter dish.
Yeah,
So it's bigger.
it's
Yeah.
bigger.
And they are building the world's largest steerable radio telescope. So that should be coming online in a couple of years.
Yeah,
Um, the 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 folks behind, like the National Science Foundation, they're building an advanced version of the Very Large Array, which should, which is going to span pretty much all of North America. So it's going to be hundreds of radio dishes from Canada through the U.S. into Mexico, and will be just dramatically more powerful than the Very Large Array, the next generation Very Large Array. And then of course there is the square kilometer array.
yeah, that one. These things take decades and
Yeah,
multinational
2030s.
agreements. Yeah,
Yeah, and so I think that's part of it, is that people said we could rebuild Arecibo, but you've got FAST, which
yeah,
is big, and the Chinese are bringing international collaborations. People can do their research on that telescope, and then you've got the next generation Very Large Array and the Square Kilometer Array, which will push into dramatically different wavelengths. So um, it's kind of like canceling Sophia.
yeah.
Like James Webb does everything Sophia could do.
There's
So
still
Sophia,
sadness involved because everything is
totally,
oversubscribed and it was a sweet little
yes,
instrument.
yeah, but it is able to do a fraction of the science. It can look at the moon, which is a thing that James Webb can never do.
Yeah.
So, yeah. What's coming up next? What are you working on?
Right now, I'm getting ready to go to Baltimore to Balticon. I will be there this Friday, Saturday, Sunday, Monday. I'm then going down to Orlando to meet with a colleague down there, and I will be doing a meetup there as well. I will be sending out all the details on Patreon and posting them on social media. Um, and one of the things that we're also getting ready to do is a cleanup of the Astronomy Cast website. Anyone who's looked recently, we just put like 20 new transcripts up. Big things are starting to happen. Um, if you're not supporting us on Patreon, you're not getting notified of what all is going to happen. And I'm looking for ways to really engage our Patreon community more. So let me know if you have ideas, everyone.
So I have an idea for you, which is that you don't actually have to become a patron to follow us on
That is
Patreon.
true.
There's a free
Yes.
version of
Yeah.
Patreon. And so one of the things that a lot of people do is you just go onto Patreon, follow us,
Hmm.
and you'll get notifications about a
Yeah.
lot of the stuff that we do, a lot of the stuff that we release for free. You'll get that content. And then you'll also see the stuff that's only being available to the patrons and
Ad
can decide from
free.
there. But
Ad
yeah, the
free.
ad free and so on. But if you just want to, like, it's been described as a nice bookmark. If
Yeah.
you want a way to bookmark what a creator is doing that is really interesting, definitely check out our Patreon. So patreon.com/astronomycast.
Yeah. I'm typing it into the chat.
All right. Well, I think we've reached the end of our hour. It is time to roll. So thank you, everybody, for hanging out today. It's great to be back and doing Astronomy Cast. And then remember, we've got another 7 episodes. No,
I think it's
five?
less. It's
Five?
it's it's.
Yeah.
We're taking next Monday off because it's Memorial Day.
Yeah.
And that leaves us
So
four
four.
more episodes. We
Yeah.
have
Four
four
more
more
episodes.
episodes.
So thank you, everybody. Thanks, Pamela. Thanks in advance to the editors who are going to have to deal with this nonsense. And we will see all of you in 2 weeks.
Bye bye, everyone.